Our Earth is covered in rocks, but how are all these rocks made? And how do they get to places like way up here? Morning, Mrs. Parker.
Before we get started, we have a couple of key terms. Geology. Geo, meaning earth. Ology, meaning study of. Study of earth. Geologist, a scientist who studies earth. Here's a couple of essential questions to look for in today's video. What are the three types of rock? How are each type made? And how does geology affect our everyday lives?
Earth is a sphere, just like this ball. But unlike this ball, the Earth is made up of several different layers inside it. We're going to use an apple to model the Earth. The outside of the Earth, the part that we stand on and the part that we see, is called the crust. The crust is mostly made up of solid rock. If we cut into the apple, you can see the crust doesn't make up much of the apple. It's a very thin layer on the outside. Once we move past the crust, we get into the mantle. The mantle is made up of liquid rock. Further down from the mantle, we get to the core. Our planet has a solid core. It's made up of extremely hot metal called iron. That's good science right there.
Rock formations like this one make for great climbing.
If all rocks are made deep under the earth, then why do we have so many different types of rocks? Rocks are made in three distinct ways, and here on Earth we classify them into three categories. We have sedimentary rocks, igneous rocks, and metamorphic rocks. Igneous rocks are formed by the cooling of magma. Magma is liquid rock. As the magma rises under the earth, it can cool on its way to the surface, forming rock. It can also be spewed out of volcanoes as lava. Once the liquid rock is spewed out of the volcano, it starts to cool. That can also form igneous rock.
This is a basalt rock formation in Berkeley Heights, New Jersey. Basalt is a type of igneous rock that forms when liquid rock called magma cools. As basalt cools, it forms these columns, vertically up and down. As the rock breaks down over time and cracks, you can see these massive fault lines and cracks running all the way through the rock. Also, while igneous rock cools, air tends to get trapped in the rock itself. It leaves these little air bubbles that we can still see today. That's one of the strategies we use to identify igneous rock. Geologists can look at a rock formation like this and tell by the structure and the color all kinds of different things about this area. Glaciers from thousands of years ago slid through this area, scratching marks into the rock. And we can still see some of those marks in the rocks today.
Another type of rock is sedimentary rock. Sedimentary rock is made up of sand, dirt, shells, and other bits of small rock. As these come together, they're pushed deeper under the earth and get squeezed together to form sedimentary rock. In this sedimentary rock, we can see the distinct lines from different layers being laid down in the formation of this rock. Because sedimentary rock is laid down layer by layer, it's an easy place for the remains of animals to get trapped and fossilized. Metamorphic rock is formed deep under the earth. As rocks get pushed down into these deeper layers, the extreme pressures squeeze and the extreme heat cooks these types of rocks to form new rocks. At these temperatures and high pressures, rocks like limestone can be turned into marble. Here's some geology you can do inside or outside of your very own home. The first thing you want to do is get a collection of rocks. You don't have to go far. You can check the front yard, the backyard, or near the driveway, and there'll be plenty of rocks to choose from. Try and get a wide variety of rocks, both in size, shape, and color. Next, you're going to want to take those rocks and you're going to want to clean them off. You can run them under the faucet or even use a sponge just to clean them down a little bit. Most rocks that you find outside are going to look brown. And the reason they look brown is because they're covered in dirt. Once you get that dirt off, then you'll really start to be able to see the features of the rock. Once you have your rocks cleaned and laid out, you can start to look at some of the features of them. The first thing you want to notice is the texture. You'll notice that a lot of these rocks have smooth sides, but some of them, like this one, are very rough. You can also begin to look at the color of the rock. Most of these rocks are one basic color, but if we look at this one here, we can see it's filled with all sorts of different colors. This tells us that this rock is made up of many different minerals. We can see in this rock some very large crystals and another rock. For this part, you're gonna wanna put on some sweet safety spectacles like these bad boys. We're gonna be using a hammer and a flathead screwdriver to chisel off some pieces of this rock to take a look at what's going on inside. I'm gonna take one of the rocks that I know is a softer rock. To chisel my rock, I wanna put it flat on something that will protect my countertop. I'm gonna put the chisel in a nice notch where it won't slip, and then gently tap it with the back of the hammer. This rock came apart pretty easily, but if we look inside, we can see some of the minerals and crystals that have formed inside there. Some of the harder rocks proved much more difficult to crack, but once I found the lines and lined up my chisel, I was able to crack them straight open. We can see here the different layers of this rock. This rock was probably made layer by layer over a long period of time. This last rock cracked right open to reveal its inside. We're going to take a trip into Pennsylvania to try and uncover a geologic mystery.
When rocks form deep underground, they come together in different ways. This can give them some pretty interesting characteristics. Here in this boulder field in Pennsylvania, these rocks have some distinct characteristics. When most rocks are struck, they release a dull sound like this. Some of the rocks in this field, though, release a distinct ringing sound. Even though geologists have taken samples and studied these rocks, they're still unsure to this day what causes the ringing.
Cool story, bro. Rock's like a billion zillion years old. Who cares?
That's a great question, Guy on Couch. Why do we study these rocks from millions of years ago? Well, first of all, take a look around your room. A lot of the things around you are probably made up of rock. The floor and the foundation of the house that you're in right now is probably made up of cement, which is just a mixture of different types of rocks. The glass of all your windows is also melted down rock. Many of the materials that we use every day, like metals and plastic, are extracted from the earth, not to mention all the minerals located within your electronics. These minerals are buried deep under the earth, and geologists are needed to find where to dig for these minerals. Once geologists determine where these minerals are, excavation crews can come in to extract them. Here on Earth, we have three main types of rock: sedimentary, igneous, and metamorphic. Our planet is made up of several different layers: the crust, the mantle, and the core. As rocks are pushed up and down through those layers, they can form different types of rocks. We call this the rock cycle. Our planet's made up of rocks. These rocks can tell us where our planet's been and help us predict where our planet's going.
One of my favorite things about geology is no matter where you are, you're always near a rock.
Things like limestone can be transformed into marble, coal can be turned into diamonds, and I don't have a third one.
This area is known for rocks being pretty neat. It's pretty neat, right? That rock is pretty neat.